This is Mrs. Wainwright's math class, Chapter 1, Lesson 6A, using left-end estimation. Our learning target by the end of today's lesson, we should confidently be able to say, I can multiply using left-end estimation. So today's lesson is not about actual answers, it's about estimation. When you estimate a number, you're finding a number that's close to the actual number. Why would you do that? We often estimate when we don't need an exact answer, because once we get the hang of it, estimation is actually quicker and easier than doing the exact math. And before solving an exact problem, it's a great idea to quickly estimate the answer to be sure that our actual answer is reasonable and makes sense. We want to make sure we didn't make a mistake. So let's see how we do at left-end estimation. The best way to find a general quick estimate is to use left-end estimation. I had to do some changing when I made this screen, and notice that I left my dot for my I behind, so now my dot for my I is underneath the N. Well, we'll ignore that and pretend it's on top of the I where it belongs. This lesson will break left-end estimation down into steps. But the goal is to eventually be able to do this mentally, that means in your head, without pencil and paper. You must show all steps that are shown in this lesson on this worksheet. However, after that, when you truly feel you can correctly estimate mentally, see a teacher in class. We'll give you 3 problems, and when you can correctly estimate 3 problems in a row, and that's 3 problems we give you after you've spoken to us about it, we will let you know if you're exempt from showing the work for the rest of the time. So again, it has to be asked of a teacher ahead of time. You have to do the 3 problems we give you in a row correctly, and then we have to tell you that you're exempt from showing the work. Until that time, you are expected to show work. So let's check it out and see how it's done. In example number 1, I'm given the number 234. I want a quick and easy estimate for the number 234. Well, when I want a quick and easy estimate, I do use left-end estimation. What does that mean? I need to find the digit all the way on the left side. If I look at 204, the digit all the way on the left is the 2. I'll underline the 2 because it is my left-end digit. Now I have to decide what it's going to round between. 234. What's the lowest number it would round to in the hundreds, and what's the highest number it would round to in the hundreds? And here's how we figure that out. First we take the underlined number, the left-hand digit, which is 2, and we copy it. Then we see how many digits are after that and turn all of those digits into 0. I have 2 digits after that, so I will put 2 zeros after my 2. So if 234 were to round down to the lower end, it would round to 200. Now I have to figure out what the higher end it would round to. How do I do that? I go back to my underlined digit, and I add 1. 2 plus 1 equals 3. Write it down. Every digit after the underlined digit turns to zeros. I have 2 digits to the right, so I will have my 2 zeros. So if 234 were to round up, it would round to 300. Now that makes sense, because on a number line, 234 is indeed between 200 and 300. If you look at your rounded numbers and your actual number, you'd see that they go in order from smallest to largest. 200, 234, 300. That is going from small to large. So those numbers do make sense. Now I take the number to the right of the underlined number, and I circle it. This number is a 3. This number will tell me whether I round down or up. How does the number tell me if I round down or up? Well, think of it like the Island Tree schools. Grades K to 4, and K isn't a number, so that's kind of like 0. 0 to 4 are down in the little kids' schools. So if your circle digit is 0 to 4, which is 0, 1, 2, 3, or 4, it rounds down. And in the Island Tree schools, grades 5 to 9, because it's only single-digit numbers, so we wouldn't count 10 or 11 or 12. So grades 5 to 9 are up in the big kids' schools. So just like the Island Tree schools, if my circled number is a 0, 1, 2, 3, or 4, I round down because it's in the little kids' schools. If my circled number is a 5, 6, 7, 8, or 9, I round up because that's in the big kids' schools. So in this problem, what's my circled number? It's a 3. Is that going to round down to the little kids' schools or up to the big kids' schools? Of course, it's going to round down to the little kids' schools, so it's going to round down to the 200. So using left-end estimation, 234 estimates or rounds to 200. Please stop the video and do worksheet number 1. Again, go back to this slide, step by step, start from the beginning, stop it as you go, and do each step with me as you solve worksheet number 1. So for example 2, I'm given the number 78. I want a general estimate, so I'll use left-end estimation. That means I underline the digit all the way to the left. My left-hand digit is 7. What would it round down to? 7 stays the same, and every digit after that turns to 0. I have one digit after that, so 1, 0. What would it round up to? Well, I add 1 to my underlined digit. 7 plus 1 equals 8. And every digit to the right turns to 0. I have one digit to the right, so that would be 1, 0. I circle the number to the right of the underline, which is an 8. And I think 8, is that down in the little kids' school or up in the big kids' school? Well, 8 is in the big kids' school, so that equals up. And if I'm rounding up, 78 would round to 80. So using left-hand estimation, 78 rounds to 80. Please stop the video and complete worksheet number 2. Example number 3, I'm given the number 41,395. I need a general estimate, so I'll use left-end estimation. That means I underline the digit all the way to the left, which is my 4. What would it round down to? Well, the underlined digit stays the same. Everything to the right turns to zeros. Notice something on this problem, though. I have a digit and a comma, digit, digit, digit. So I have 0, comma, 0, 0, 0. Keep the commas in. Okay? Now, what's the high end that would round to? I would take my 4 and add 1, which is going to equal 5. Again, I have digit, comma, digit, digit, digit. So I do 0, comma, 0, 0, 0, kind of like a pattern. I circle the number to the right of my underline, which is a 1. And I think is 1 in the little kids' school, which is down, or up in the big kids' school. 1 is in the little kids' school, so that means down. 41,395 will round down to 40,000. Please stop the video and complete worksheet number 3. And example number 4 is more like the real reason that we're learning left-end estimation. The directions say find an estimate, and I have the actual problem, 863 times 8. If I want to find an estimate, I can simply use left-end estimation. So first I'll focus on my top number, which is 863. The digit on the left is 8. 8 stays the same. I have 2 digits to the right, so I will add 2 zeros. On the right-hand side, I add 1 to my underlined digit, so 8 plus 1 is 9. I have 2 digits on the right, so I add 2 zeros. Circle the number to the right of the underline, which is 6. 6 a big kid's school or a little kid's school. 6 is a big kid's school, so 6 means I round up to 900. Now I'm going to take a look at my next number, which is an 8. That's a single-digit number, and you never estimate a single-digit number. You always keep it as is. So therefore, my new problem would be 900 times 8. We know to solve this problem, we're going to do basic facts. So 9 times 8 equals 72. I have 2 zeros, so I tack on my 2 zeros. This is a whole number with more than 3 digits, so I'm going to count back 1, 2, 3, comma. And my final answer is 7,200. 863 times 8 is about 7,200. Please stop the video and complete worksheet number 4 right now. For example number 5, again we're going to estimate. We're given the problem 2,514 times 6. And if I'm finding a quick estimate, I'm using left-end estimation. Take my 2,514, left-end digit is 2. Copy the digit and turn everything else to zeros. I see that I have a comma, 0, 0, 0. On the right side, add 1 to that underlined digit. 2 plus 1 equals 3. Turn everything else to zeros, so I have a comma, 0, 0, 0. Circle the digit to the right of the underline, which is a 5. 5 means we round up to the big kid's school, so that's going to round up to 3,000. 6 is my next number, but that's a single-digit number, and we never estimate single-digit numbers. We keep them the same. So therefore, my new estimated problem is 3,000 times 6. Again, we're going to do basic facts here, and 3 times 6 is 18. I have 3 zeros to tack on. I tack them on. I count backwards for my comma. 1, 2, 3, comma. My final answer is 18,000. So 2,514 times 6 is about 18,000. Please stop the video and complete worksheet number 5 right now. And for problem number 6, we're given the problem 74,986 times 5. We need to find an estimate. So again, we'll use left-end estimation. I'm going to show you the way I would do it in my head mentally. I go through all the steps and say everything, I just don't write it all down. So in my head, I'm going to say, okay, my left-end digit is 7, so it's either going to round to 70,000 or 80,000. The digit to the right of the 7 is a 4. That's a little kid's school. That means it will round down. So 74,986 rounds down to 70,000. I look at my next number, which is a 5. That's a single digit. I don't round single or estimate single digits, so I'll say times 5. I have the problem 70,000 times 5. I'll do my basic facts, which are 7 times 5 is 35. I have 1, 2, 3, 4 zeros to add. 1, 2, 3, 4. I count back for my commas. 1, 2, 3, comma. 1, 2, 3. That's it. I'm good. My final estimated answer is 350,000. So 74,986 times 5 is about 350,000. When you do this problem on the worksheet, you can choose to show all work if that's easier, or to do it in your head like I did here. Please remember, it's fine to show all work. It will eventually come to you that you'll be able to do it in your head. So do what you need to do to get the answer correct. Please stop the video and complete worksheet number 6 right now. So let's review today's lesson. When you estimate a number, you're finding a number that's close to your actual number. We often estimate when we don't need an exact answer, because once we get the hang of it and can do it in our head, it's quicker and easier than doing the actual math. And before solving an exact math problem, it's a great idea to quickly estimate the answer to be sure that our actual answer is reasonable, so we didn't make some type of crazy mistake as we were doing our math. To estimate a number using left-end estimation, we find the left-end digit and underline it. We copy that digit, and we turn every digit to the right of that into zeros. 2 digits here, 2 zeros. For the higher end estimation, we take the underlined number and we add 1, which turns this to a 3. Everything to the right turns to zeros. We put our 2 zeros. We circle the number to the right of the underline. This circled number tells us whether we will be rounding down or up. And to decide this, we think of the Island Trees schools. Grades K, or 0 through 4, are down in the little kids' schools. So if our circled number is a 0, 1, 2, 3, or 4, we round down. Grades 5 through 9 are up in the big kids' schools. So if our circle digit is a 5, 6, 7, 8, or 9, we round up. In this case, our circle digit is a 3, which means it rounds down because that's a little kid's school. So this 234 rounds down to 200. And finally, we estimate numbers that are 2 digits or more, but whenever we have a single digit number, we do not estimate it. Single digits stay the same. Good luck with this lesson.